Hello, and welcome back to this course on NumPy. NumPy is arguably one of the most important Python packages in existence today, and forms the basis for a whole host of other Python packages that span a wide range of industries and uses. So in this video, we're going to take a look at some background about NumPy. What is it? What are some of its features? And what are some of the applications for NumPy? So first, what is NumPy? So NumPy is essentially the fundamental package for scientific computing in Python. NumPy provides us with a means to work with large multidimensional arrays and matrices, which are useful in a whole host of applications, from image processing to machine learning to data science. Think of it as a tool that converts Python into a powerful data analysis and mathematical toolkit. And beyond just offering support for these data structures, it also brings to the table a comprehensive collection of mathematical functions that enable us to perform operations on these arrays seamlessly. So what are some of the specific features that this involves? Well, as I mentioned before, the hallmark feature of NumPy is its n-dimensional array, which acts as a fast and incredibly versatile container for large datasets. These arrays are much better optimized than basic Python lists, and they have a range of useful features. Alongside these data structures, NumPy is equipped with a vast array of mathematical functions, covering everything from basic arithmetic to linear algebra and statistics. Now, all of this is tailored for memory efficiency. Its arrays are designed to share memory and carry out operations without unnecessary copying, further optimizing its speed. It provides neat features like broadcasting, which allows arrays of different shapes to be operated on together. Basically, if you can think of a mathematical or scientific application for large arrays of data, NumPy pretty much has you covered. So what are some uses of NumPy? Well, since NumPy provides for Python this fundamental data container that is extremely well optimized compared to other Python data types, NumPy has found uses in almost any scenario you can imagine. It's used in data science and data analysis for containing data and applying statistical operations to it. It's used in image processing, and later in this course, we're actually going to take a look at the library OpenCV as an example of how powerful NumPy can be. In image processing, images are usually stored as 2D or 3D arrays of pixels. And so NumPy allows us to manipulate and apply mathematical operations to these arrays quite easily. NumPy is also used in machine learning, with NumPy data structures being found in foundational machine learning libraries like TensorFlow and scikit-learn. And it's also found use in general academic and scientific computing, such as creating mathematical models of phenomena and simulations. Finally, NumPy could even have a place in game development, with its high-performance arrays being amenable to things like physics simulations and the ubiquitous matrix and vector math that we find in gaming and graphics programming. Really, the strength of NumPy lies not in what you can do with NumPy alone, but in the fact that NumPy provides the mathematical and data structure foundation for all these other libraries and tools. This is why, no matter which one of these areas you hope to study further, some foundational knowledge of how NumPy works is going to always be essential. So this has been a basic overview of the NumPy library, and in the next video, we'll get our environment set up and start diving into the code. So thank you for watching, and I will see you in the next one.